Hey, hello, everyone. Welcome to today's webinar in the AMATYC 2021 webinar series, an introduction to statistics, a modern approach. Our presenters today are Minay Chetinkaya Rundle and Joe Harden. Any views expressed by the presenters are not necessarily the views of AMATYC, and any commercial products mentioned are not endorsed by AMATYC. McGraw-Hill is the sponsor for the 2021 AMATYC webinar series. If you are not a member of AMATYC, we would love to have you as a member. Please consider it. You can sign up at our website or get more information from our many Facebook pages and groups. There are other professional development opportunities through AMATYC, conferences, webinars. And as I mentioned earlier, the recordings will be found on our AMATYC website under the webinars page. Not only today's, but all past webinars are there for you to browse at your leisure. So at this point, I will stop my sharing and I will turn it over to Minay and Joe.
All right, thank you very much for having us. So I am Minay Chetinkaya Rundle. I am a professor of the practice at Duke University, and I also work as an educator with our studio. And joining me today is Joe.
Hi, I'm Joe Harden. I'm at Pomona College, which is a small liberal arts college in Southern California.
And I am located in North Carolina, Durham, North Carolina. So thank you very much for joining us today. We're going to be talking about a modern approach to teaching introductory statistics. And the reason why the two of us are giving this talk together is that we have recently published a book together called Introduction to Modern Statistics. It is an open source book, and part of what we're going to discuss today is the pedagogical approaches and kind of what we believe makes this approach to teaching modern. And part of what we're going to talk about is how to use this resource in your teaching. So before we get started with the content, I'd like to ask a couple polling questions. So I think Pat will help put these in place for us. Our first question is, how do you identify a mathematician, a statistician, a computer scientist, or something else? So go ahead and add your answer. And then once we have all of the answers, we can maybe share the results with the audience. So lots who identify as mathematician and a fewer statistician. If you've gone for something else and feel up to it, do feel free to share with us in the chat what that something else is. And next, one more question. How often do you teach intro stats? Every semester? Sometimes. I've taught a few times in my career, or not yet, still waiting for my chance. And again, once we have answers from everybody, we'll share the results with you. So lots of us teaching intro stat every semester. And it seems like at least everyone has at least taught it once. So hopefully that's probably why you're here, which makes sense. And hopefully lots of what we're going to say will make that you'll be able to kind of identify with. All right. So our approach to teaching introductory statistics, we can kind of group it into these three categories. Start with graphics, then on to modeling, and wrap up with inference. And I think importantly, hopefully leaving them wanting to learn more. So our goal with this introductory statistics curriculum is not to teach all of statistics, but teach a curated and carefully selected portion of what fits into the introductory statistics curriculum, not necessarily trying to stick to what has already been there. And then hopefully, having return students where they can learn some of the stuff we didn't get to teach them in the intro stat course in a future class. So one other question about data visualization. Visualization is a big part of what I teach in intro stat. part of just-in-time teaching. So for example, if you need like a box plot within ANOVA, emphasized only as a method of descriptive statistics, or not something I cover in intro stat. Which of these fits your teaching the best? I think the poll went away. There we go. So let's take a look to see what the results look like for this one. So many of the most popular answer here is emphasized only as a method of descriptive statistics. A quarter of the folks said that it is actually a big part of what they teach in intro stat, which I think is closer to what we'll be kind of highlighting here. So in this curriculum, we start with data visualization. That is sort of the first thing students learn about, and it is how they start to look at data, not necessarily just in tabular format, but as a visualization. And to begin with, we start with bivariate visualizations. This is an image from the first chapter of the textbook, for example, where we're looking at the relationship between population change in counties over 7 years versus the median household income, where we're seeing slightly positive relationship, somewhat strong, and we've also annotated it as well. So the idea here is that instead of starting with univariate visualizations, to start with visualizations that describe a relationship, and then where needed, go to univariate visualizations to kind of describe a single variable, particularly if needed for things like assumption checking. But then we quickly move on to multivariate visualization. So these are also examples of visualizations where we have at least 3 variables presented. So one of them is about animal names and whether certain names are more likely to be cats or dogs. And the other one is about how countries vote in the United Nations for particular issues that the resolutions tend to be about. And we have multiple countries represented. And you can see that both of these visualizations share some common things. There's annotation happening. There's multiple variables that are being presented. And a lot of what the students do early on is both interpret these visualizations, and a little bit later in the presentation, we'll talk about how we teach them to make these visualizations as well. And importantly, I think introducing non-standard visualizations. Now, non-standard, what I mean by this is that not perhaps standard to many introductory courses. There's nothing very outrageous about this visualization where we have the most common password. So this was a data that was based on like hacked passwords. But you can see, for example, that the data points are represented as the words they are, as the passwords that they are, as opposed to just points to represent data points. And they are clustered for particular issues. So there is, again, lots going on in a single visualization. And quickly we get the students to a point where they can't just look quickly at a visualization and interpret it. They actually have to stare at it for a while to get a sense of what the visualization is telling them, because there are multiple variables represented using different aesthetic components of a visualization. And also to not just bury visualizations in the descriptive portion of the class, which tends to be maybe like the first quarter or third of the semester, but carry it throughout and use visualizations beyond just data exploration, but also to allow kind of conclusion making and decision making when we're doing inferential problems. And so here we're seeing a histogram of bootstrap proportions, but we're going to say more about that in a bit. Then we move on to modeling. So instead of going on to inference, our next step is going on to modeling. And modeling, we teach it in kind of three topics. between modeling for two numerical variables, so a simple simple linear regression, but then quickly moving on to multiple linear regression. So the students aren't just saying there may be a confounder we should be careful about, but very quickly learning how to quantify how that confounder might factor into the relationship between the two variables. And then also teaching them logistic regression early on, where the outcome variable is categorical. Here, we're talking about modeling only in the descriptive sense, as in they are fitting models and interpreting the coefficients of those models. But if you think about a standard linear regression output, we're not talking about that standard error and p-value column just yet. So the idea is, through visualizations and descriptive statistics, we've been able to look at things like relationships between one numerical and one categorical variable, maybe with side-by-side box plots. And maybe we've been able to, compare the medians across box plots. Well, similarly, we should be able to quantify early on the relationship between two numerical variables. So that's regression. So we're doing exploration, then we're doing modeling. And then we're moving on to inference. So before we move on to inference, any questions so far about anything we've said?
I noticed there is a question, raised hand, but I don't know what to do with that. Pat, do you know how to ask that person?
Let's see, Teresa Moore, I don't know if you realize that you raised your hand. And then Margaret, if you do have a question, you can just type it into the chat. That way it's there and we can all see it and go from there. It looks like they both put their hands down.
Okay.
So I think those are accidents.
All right, so going forward, feel free to plop them in the chat and I will pass things over to Jonah.
Great. So I'm going to talk a little bit about inference, and inference is, personally, what I think makes this some of our work more different than most introductory curricula. But I wanted to, before I jump in, I want to just put out there that, Mina and I have this fantastic collaboration, and I think we are aligned in so much of what we think about with intro stats. But I think that one place that we differ is the number of weeks or the amount of time spent on the different parts of the different pieces of the intro curriculum, and where I think that introduction to visualization is incredibly important, and starting with the modeling before we get to the inference, I actually would probably put those at a lower percent and start the inference section a little earlier, and maybe then trickle in some of the visualizations more as we move on. So just throwing that out there, that we're putting out one of our perspectives on this and thinking like, oh, there's a lot of different creative approaches that we can take to implement in our own classrooms. Maybe I'll just answer this question before I jump into this inference stuff. So, we both teach at schools where I think, you can correct me if I'm wrong, but my intro stats is like reasonably, it's not a liberal arts intro stats, like they're science majors or they're math majors or whatever, and we're teaching a reasonably sophisticated intro stats. But my understanding is that our materials have been used at people with all levels. So even at the community college and high school level, maybe not this particular book yet, as it's just recently been out. Mina, do you want to speak to that a little bit?
Yeah, so at Duke, we just started using this book in this curriculum. So this is for our intro stat course that's open to everyone. In fact, a large percentage of the students in that course are social science majors, public policy, political science, humanities. A lot of our students who are early on planning to be statistics majors actually tend to take our data science course. And this course is certainly open to other, stats and math majors as well, but it tends to be mostly social science students at Duke.
Great. Okay, so I'm going to talk about three different aspects of, what we think about as sort of this inference umbrella, where the inference umbrella is thinking about, we have a sample of data and we'd like to say something about a population. And so the three pieces here are hypothesis testing, confidence intervals, and model validation. And the approach that we've taken is to introduce modern / computational methods side by side with standard central limit theorem approaches. So for example, with hypothesis testing, for all of the standard hypothesis tests, we've introduced how one could do this using a randomization approach. So we have a randomization approach for the two sample mean and the two sample proportion, and even for the many means, the ANOVA situation. And then we do the same thing with confidence intervals, except with confidence intervals, instead of doing randomization to force a null hypothesis, and I have a few slides on that, sort of kind of how we do that. But with confidence intervals, we're using a bootstrapping approach. So bootstrapping approach, again, is that sort of more modern computational idea that we're not relying on the normal distribution, we're not relying on the central limit theorem, but we're able to generate confidence intervals for whatever parameters of interest. And then the last thing is the idea of cross-validation, where we leave out a little bit of our data set, we run a model, and then we say, okay, how well does it predict, with the idea of that sample population paradigm, where that model that we've left out could be representative of, the data that we've left out could be representative of data in the wild. Okay, so I'm gonna go through all of these. You can go ahead. And before I get to those sort of three, I just wanted to, there's a lot going on these slides. This is just basically the table of contents, but just to kind of see there that, on the left side is chapter 17, and that chapter or section 17.1 is that randomization for the difference in proportions. 17.2 is the bootstrap for the difference in proportions. And then 17.3 is that mathematical approach, the central limit theorem type approach. And that we use that same structure throughout, really for pedagogical reasons, for the students to see these methods as approaching this problem, this two sample proportion problem, and that they can approach it in a variety of ways. And after I give some examples, I'll talk about why we think that multiple approach is really beneficial for learning. Sorry, stay back one more time. One more, sorry. And just also to point out that, for example, in the ANOVA situation, we only have that section, the 22.2 there is the randomization approach. And I'm sorry that this is pretty small. Hopefully people can see it. Is the randomization approach. And then 22.3 is the mathematical model. And for those of you who have taught a lot of introstats, including the many means, the ANOVA, which is, like, are these three means identical? There's not sort of a natural confidence interval method. You can go back to the two mean confidence intervals, but just kind of recognizing that this structure, is very deliberate and is trying to really fit into the applications that students will see as they leave our classes. Okay, now. Okay, so the example I want to show you about hypothesis testing, again, is comparing this parallel structure. So we start with the randomization approach, and then within that same chapter, we see the t-test. And I've just provided a few sort of screenshots here of some of the things we do. This particular example is about a test, like a midterm exam. And students are given two different versions of the exam. They're either given version A or version B of the exam. And the null hypothesis here would be that, the student sort of has an inherent score, like they know the material at some particular numerical value, which is kind of a silly thing to assume, but that's the null hypothesis assumption. So you start all the way on the left side of this screen, and you see that these, 1, 2, 3, 4, 5, 6, 7, 8, 9, these 9 students have these scores that they've gotten on their tests. But if the null hypothesis is true, then it wouldn't have mattered what test they got, right? Which version of the test. So we could have given, score 69, we could have given that person test B, and they still would have gotten a 69 if the null hypothesis is true. So Yeah. So, so this is this process, and we really use graphical or visual examples to help students understand both the null hypothesis and the idea of a sampling distribution. So again, most of you have taught intro stats before, and I'm guessing that you're in agreement with me that the sampling distribution is the, if you know, one of the, if not the hardest topic to teach, is like, what is going on with a sampling distribution and why would I even do that? So, you know, working through this little graphic we have on the left and then repeating that over and over and saying, okay, what happens when I have like all these different X bars? Then we get to the t-test and we are ready to go with like, what is this test statistic and why would it change from one sample to the next, and what would it even mean to have a distribution? So so really trying to use the randomization test to help inform what's going on with sort of those central limit theorem ideas. Okay, so kind of same idea with the confidence intervals. So on the left, what we have is a 2-sample mean situation, and we have the example is maybe like 2 different car dealerships, and we want to know the price of the cars on average. And so we take a sample of 5 cars from each of the car dealerships. Sorry, we want to know sort of the confidence interval, right? An interval estimate for the difference in average prices at these 2 dealerships. And so we take an average from the one population and an average from the other population. And boy, wouldn't it be nice if we could keep doing that, if we could just take lots and lots of samples, but of course we don't have the resources to do that. And so we use those samples as a proxy for the population, and we resample from the samples. That's the bootstrapping idea. Bootstrapping just means that you resample from the sample, and you pull yourself up by your bootstrap, and you get all of these separate bootstrap samples, and the histogram below those bootstrap samples then represents the sampling distribution of the statistic, where the statistic now is X bar 1 minus X bar 2. And we can see, oh, this is really awesome that we can see this variability, even though we didn't have to go back to those car dealerships and take more of those original data. And then we pivot to the T intervals and we say, hey, you know, we understand and we can use these computational methods. We understand the sampling distribution, but if conditions are right, we also have these lovely mathematical formulas, you know, where now we're talking about the margin of error and we're talking about the standard error. And we really have all those tools to help the students kind of navigate what that would even mean. What is a standard error? Okay, and then when we get to modeling, we really, again, want to reinforce these ideas of sample and population. And on the upper right is that sort of standard linear model output, which has, you know, the coefficient value for the slope and the intercept, and then the standard error and the test statistic and the p-value. And so much of inference does so much of inference is really focused on that p-value, right? We as a society have become addicted to these p-values, and it's not the whole story, right? So so the idea on the left is using sort of, again, these graphical ideas, these visualizations, to think about how could we represent to the students what's happening with the sample and population idea. So what we've set up is the structure of cross-validation. What does cross-validation mean? It just means that I'm removing some proportion. In this case, we're breaking it into 4 groups. We could have broken it into 10 groups, or, you know, there's lots of options there. But in this case, we've broken it into 4 groups. And we use the 3 groups to build the model. And we take that model and we predict on the holdout sample, the little blue triangle of data, we predict what the observations would be. In this case, I don't know how many of you are familiar with it. This is a penguin database, a penguin data set, where we're trying to predict how much the penguin weighs based on the length of their bill. So that's what we're doing with that holdout sample. And we can not only ask, you know, how does this model do in the wild, right? With the population, right? How, when you take your model out of the, you know, this particular data set, how will it perform? But we can also use cross-validation, and we don't get into too much detail with this in the textbook because it's at the introductory level, but we can also use it to say things like, okay, in the wild, is bill length the thing that's going to be predicting body mass better, or is it bill width, right? The width of the bill. And so kind of thinking through ideas of variable selection and whatnot, just again, to get them sort of recognizing that p-value isn't just this magical number that's the only thing that can help us understand samples and populations. Okay, so just to kind of reflect on those examples and sort of our approach and what all of our thinking has been over the years to building this structure, is that we really believe that some of these modern methods capture the inference structure that we've been teaching with, like, you know, doing t-tests by pencil for the last 50 years. Right. So again, what is a sampling distribution? What does it mean to make claims about a population based on a sample? So those ideas, those really bigger picture ideas, we believe that this parallel structure really helps reinforce. Another benefit is that more and more of these methods are being used frequently in industry. And so just kind of having our students conversant in things like what is bootstrapping, what is cross-validation, just having seen those concepts before, I think are more important for the students coming out of college today. And maybe most importantly, I sort of mentioned this at the very beginning, that you set yourself up to this question, which they're going to ask you, like, which method is better? So next slide. So, you know, we kind of think like, oh, we could have a classroom discussion about it. So for example, you know, you can start thinking about, what about the data structure? What's the distribution of the data structure, the variability, the outliers, the sample size? What should that method be able to assess? And then talking about what makes a method good. Most of my students, if I ask them what do they want in terms of type 1 error, they'll tell me that they want 0 type 1 error. And I'll tell them, awesome, I got a great test for you. Ready? Don't reject. Then you have a 0 type 1 error. If you never reject anything, then you get a 0 type 1 error. And of course that's silly, but my point is that, you know, a good type 1 error doesn't necessarily mean just 0 type 1 error. And that usually we think about a good type 1 error in relation to type 2. So a type 2 error, right, is going to be the power of the test, or 1 minus the power. And so really kind of having the students think about, well, which method would be better? Well, what does that even mean better? And how do we even think about that? And similarly with a confidence interval, you know, I'll ask them, what would make a confidence interval good? And they would say, okay, well, it should always capture the population parameter. And I was like, awesome, I got a great confidence interval for you. It's for the population proportion. My confidence interval is 0 to 1. 100% coverage every single time I'll get it. And of course, again, it's silly, but it causes them to reflect and say like, oh, well, maybe that's not what I want, right? Maybe I need to think more carefully about what does a confidence interval mean. Okay, next. Yeah. And of course, there's some disadvantages. You know, most of science continues to lean heavily on the central limit theorem methods, right? So when you're reading scientific literature, you're seeing ANOVAs and chi-squareds and t-tests and p-values from linear regressions and stuff. And so having our students fluent in those methods and really, really focusing on only those methods, we believe is still pretty important in terms of them being fluent in the literature. Another disadvantage is that a lot of the software that's used really easily implements the central limit theorem methods, the t-tests and whatnot. Although we would argue that most of that software that's just doing that push of a button, it actually makes the methods more opaque. So we worry a little bit about that reasoning being, hey, it makes it easier for students to implement when it makes it so that they have no idea what they're doing. In contrast, some of the more newer packages, for example, the Infer package in R, really walks the students through the process of, randomization or bootstrapping. So for example, it says, you're going to hypothesis, then you're going to generate, then you're going to, calculate a statistic and whatnot. So it uses sort of these words that represent the action being taken. Okay, so just a curiosity, we've introduced a bunch of these computational and modern methods. Is this something that that you were taught, in your education and you feel super comfortable teaching? Is it something or that you feel comfortable teaching? Is it something you're not really comfortable, but you're really excited about and want to start working on? Is it something that you're not really comfortable with, or is it something you're seeing today for the first time? Okay, Pat, whenever you want to show everybody.
This one's taking a little longer to respond. I think the responses are a little longer to read. So
There you go.
There's still a few coming in. I'll give it about 5 more seconds.
All right, so some of you feel really comfortable, others are not super comfortable, but excited by it. And some of you are pretty new to this. I have to say that, not with this particular topic, because obviously we've been thinking about it pretty carefully for a while, but for most modern topics, I fall in that second box. In B, like I get so excited about learning things like, next semester I'm teaching a linear models class, and I've started introducing lasso and ridge regression into that. I don't know if any of you are familiar with that, and I'm like completely daunted by it, right? I'm completely daunted by like teaching them and not really knowing exactly what's happening theoretically and not really fully understanding all the software tools that I'm going to have my students working with. And but again, because I fall into this B bin, I just like plunge ahead and I just fake it until I make it. And every time I learn a little bit, and I really think that the students are super appreciative of kind of being pushed in those new ways. Okay, one more thing kind of about this. We really, we really want to celebrate the synergy that our methods have with many other freely available resources. So there's lots of amazing applets out there that can get the students thinking about the methods we've been talking about today, as well as the traditional central limit theorem approaches. So both the Rossmann-Chance set of applets that's associated with their textbook, which is called Investigating Statistical Concepts, Applications, and Methods. And then the stat key set of applets, which is by the Locke family in the, I don't know, that book's called like Unlocking Statistics or something like that. But all the applets are totally free. And giving homework assignments to have students go play with them and stuff like that, we really, really value. And then I guess this book is not free. It's a book that you would buy, but doing tactile in-class activities should be free, or whatever. And just really kind of recognizing that that there's a lot you can do beyond just what we're showing you today. Okay. Questions. I know there's been a couple in the chat already, but maybe have been answered or maybe are about to be answered in the next little bit.
Maybe I'll answer the question from Kristen, because it kind of does go with what you were just saying in terms of linking to other really available sources. So Kristen's questions was, is there an online homework component to the textbook? And the answer is yes and no. So there is an online homework component to another open intro statistics book. So not the most current one we're talking about, but the one that goes with a bit more traditional approach on My Open Math, which is an open source online homework platform. And I know that this year, as educators are adopting this book, there are a couple of them who are writing my open math versions of Introduction to Modern Statistics. So the link I put in the chat will take you to where you can learn about like how you can connect Open Intro and my open math. And hopefully we'll be able to update that link a little bit later this year or in 2022 with any sort of integration with the particular curriculum we're discussing today.
And to be clear, the book does have homework problems that are online and are free. So, but they're just not integrated. The students would have to do them with pencil or with, some kind of.
Yeah. So we do have online homework questions, and then the odd numbered ones have the answers available to the students. Yeah. And then there was another question about kind of the statistical computing tools, and I'll say a bit more about those next. So we've discussed a curriculum with you so far, and I'll like bring you back to this, the textbook where you can kind of find all of this stuff all together. And the URL is here on top, openintro.org/IMS. And here what I have is a screenshot of the HTML version of the book. That is the web version of the book. So all the ways to get it, the textbook is freely available as HTML and also freely available as PDF. The paperback is available at a low cost. So at the cost of printing, plus a minimal royalty that goes to the Open Intro nonprofit. And much of the, sometimes people ask about the finances of things. So in the interest of transparency, much of that royalty that comes back to Open Intro is actually used for desk copies for teachers. So if you would like to request a paperback version of the book as a desk copy, you can do so at no cost to you. And the way that's subsidized is with this minimal royalty that we add to the paperbacks or any sort of donations that we might get. So now kind of let's put it all together. We've talked about the pedagogy in terms of the statistical content, but what are other components of the pedagogical approaches in the book? We try to use applications as motivation. Every single chapter starts with, what if we have this real problem we want to solve, and we present it with a real data set. These data sets are recent and hopefully relatable. I feel like as I age, I have less of an idea of what relatable means to our students, but we do try to pick things that are of at least societal importance with a few sprinkled in for fun. So for example, the pet names, not a huge societal importance, but it is kind of cute and also gets students kind of interest. And we update the data sets pretty regularly. There's an emphasis on data exploration, as I said, and also an emphasis on multivariate relationships and on statistical reasoning throughout the entire book. So instead of saying, in this situation, you always must do this method, we always try to kind of walk the students through, here's how you might decide to do A, B, or C. Lots and lots of end of chapter exercises, as I said, with solutions to odd numbered questions in the back of the book, but also lots of guided practices and worked examples interspersed in the text. So you'll see this sort of kind of example boxes where we have a question and then the answer underneath it. So students are constantly exposed to sample good answers. And the guided practices are similar questions, but then the answer is hidden in the footnote, with the idea that maybe that makes the student stop for a second and not look at the answer right away, but gets them thinking, which is hopefully a good break to their reading. So next, let's say a few words about computing. And before we do that, we have one more polling question, which is, what software do you use? And mostly in the context of teaching introductory statistics. R, Python, another statistical software, applets or web interfaces, or I don't use any software. All right. So no R in the mix. Interesting. some Python, and so Excel does, of course, count. That would be under other statistical software. So you could maybe I would call it spreadsheet software, but that's okay. It is totally valid and a used tool. So if you have chosen other and would like to share with others what you use, sometimes it's so nice to hear what other people are doing. So feel free to put that in the chat. So this was kind of a leeway to the computational part of things. I don't think we can talk about teaching modern statistics without the computational aspect. Much of what we talked about, multivariate relationships, visualizing them, summarizing them, modeling them, ultimately takes some sort of software to be in use. And the software that's highlighted in the book, but when I say highlighted, I don't mean in the text of the book, but made available at the end of each of the parts of the book is R. So we have interactive tutorials that your students can run in the browser. These are linked from the textbook from each of the parts. The book is kind of separated into parts, and they come with step-by-step instructions and require no software installation. So here I have a screenshot from one of the lessons. There's about 34 of these tutorials, and you can see lots of narrative and then a code box where you would be running R code, but many of those code boxes come in this fill in the blanks type scaffolding, and we kind of take away some of the scaffolding throughout each of the tutorials. But the idea is that students can link out to these from the textbook and run them in the browser. So they are getting exposed to the implementation of the concepts they're learning in R, with the narrative that explain what each function, what each argument means, and they're able to do that in the browser without installing any software. So I think hopefully this is a useful tool in terms of working with students where maybe they are not able to maybe install software on their computers or need this additional guidance for being able to navigate the syntax. And are they screen reader friendly? So they are written in Markdown, which should be screen reader friendly. Yes, although I have to say the text I am fairly certain is, I will need to test the code boxes themselves in terms of screen reader friendliness. Like how do those fill in the blanks show up? I'm not 100% sure, but the text itself definitely is. If you would like to take things a step further, where now you want to get your students out of the browser and maybe install some software or work in the browser, but with less scaffolding, we also have Computational Labs. So these are more free-form, still step-by-step instructions, but a bit less hands-on than the tutorials. So you'll see the narrative gets a bit shorter, and they're generally designed to be completed, not just with R, but generally with RStudio. You can run R in other kind of software as well, but we have the students use our Markdown, and we walk them through this idea of writing a reproducible report as you're analyzing data. So the instructions work best if you are engaging with it in RStudio. Although we have community contributed labs that take the same content and implement it in other R interfaces. One of them is Arguro, for example, and a couple others as well that you can see on the website. And if you want to take things a step further, particularly for yourself, but maybe for your students as well, and you want to get access to all of the data sets that we're using in the textbook, they are available as an R package, which is again, open source and freely available. In fact, there's 4 R packages that kind of, if you install one, you get all 4 together that contain all of the data sets used in open intro materials. If you're using one of the, the reason why we chose to feature R heavily is that it is what is most commonly used for doing modern statistics in the real life, and therefore that's the feature. However, we also want to recognize that not everybody is teaching with R, but might very well need access to data sets. So the same data sets are also made available on the Open Intro website as CSV files or tab delimited files. And I've kind of like scroll through them just so you can get a sense of how many different data sets are featured. So if you just want to get a hold of the data set and you're not an R person, my recommendation, try out the tutorials to see how you enjoy it. It may be a learning experience for you, but at the same time, that shouldn't be a barrier to using the data sets that are featured in the book, and you can access them another way as well. I mentioned that the book is available for free and it is also open source. So it comes with a license that allows you to share and adapt, which means that you can take pieces of it for yourself and adapt it as you see fit and share it with your students. So you don't necessarily have to adopt the book in full. And now that I've mentioned open source, we'll add one last polling question before we kind of come to a close and to Q&A, which is, have you used an open source resource for your class? Yes, no, but I want to, or no? So more than half have used an open source resource, and that's really, really nice to see. And I feel like that number has been going up over the years that I've been communicating with statistics educators. And I think it's really useful to kind of consider using open source resources because they come generally at no cost to your students and can be of great quality. Many projects I'm talking about, not just the Open Intro project, of course. And for those who have answered no, I hope that maybe this has become a chance to think about, is there anything I'm using in my class that I might consider an open source replacement for? So to wrap things up, we've talked about this Introduction to Modern Statistics curriculum. There are other textbooks available via the Open Intro project with all the same they're all open source, all available for free. And we also have a bunch of teacher resources available. Things that are maybe obvious, as you can get solutions to all of the problems if you register as a teacher, to some additional things to like the My Open Math link that I was talking about earlier, all on the teacher's webpage. And another question that I tend to get a lot, which is great, is, well, this all sounds great. Is there a way to get involved? So we've also put together a Get Involved page for teachers, although this could be something you share with your students as well. If you are interested in dabbling in open source development and particularly want to do it in a way where maybe you work with somebody who has done this before and who can sort of provide some sort of mentorship as to how to contribute, we've tried to think of a variety of ways that you can contribute: finding data sets, donating exams, writing exercises, or converting them to My Open Math, writing labs or modules, translation to other languages. We have a few of our textbooks translated so far, or maybe you have your own ideas. So don't hesitate to reach out at this webpage and let us know what you're thinking. And thank you so much. The slides are at this link in the center of the slide, bit.ly/IMS-AMATYC, and we would be happy to answer any questions. There is one question from Margaret. Does the R package contain just the data, or what other packages apart from the tidyverse need to be included? So the R package for Open Intro contains just the data. It actually contains a few other things like the color palette we use for our materials and stuff. But what's most useful to somebody who is not actively working on the textbook, but using the textbook, are the data sets. Any other packages that are featured in the tutorials or the labs are explicitly stated. They all use tidyverse for data wrangling and visualization, but a variety of other packages as well, either because we might be using a data set from another package. For example, we use lots of data sets from the Mosaic project. But it might also be that we are using some functions from other packages, and we always explicitly declare them on top of the tutorial or the lab.
A question came in about different resources for students with sight impairment, and also another one. I mean, there was two questions, and we've made a little bit of progress on this front, and we have vision to make further progress, which is at this point we have all of the things that are kind of like photographs or figures have alt text to them. Not all of the like data viz, right? So if it's a data viz, like a histogram or something, we just sort of ran out of time. It's on our list for version 2 to put alt text to every single image that's in the book. Additionally, Mina has been extraordinarily careful with the coloring, and I should give you credit and let you say what you've done with your green and orange and whatnot.
Yeah, so we have, this would be for kind of sight impairments that are other than blindness, but color blindness and stuff. So we have a color palette that is colorblind friendly, and we try to make sure that in any of the figures that holds true. The textbook itself that is on the web, the HTML book, is fully screen reader friendly. So with the caveat that Joe mentioned that not every single figure currently has alt text, although if it doesn't have alt text, it probably has a descriptive caption. That is not to say that's sufficient, but it is a step in the right direction, and we're working towards kind of filling in the alt text. Actually, the ability to add alt text to books with the kind of the tool we were using to write this got added midway, so we're like trying to catch up with that. But those are some of the efforts we've made. So in the past, we used to distribute our textbook only as a PDF, which can be a bit challenging for screen reader friendliness, but I believe the HTML book has been well received in that regard. There's another question from Nelson about guide to learn what a good descriptive data analysis should have and thus teach it to students. Do you have any comments? I have some things I might say, but
you can go.
Well, so in the book itself, we don't necessarily have like a guide to a good data analysis, but something I will mention is that, each of the, and I will go to the, maybe the book website here to show this to you. Something we decided to do was to separate the book into parts, and each of the parts have chapters that, that deliver new content, but then end with a section called applications. And this is a full data analysis, maybe starting with some exploration and then going up to whatever happened in that part, whether that's inference or modeling. So we tried to write those up as with a completely new data set and as a full data analysis from beginning to end. So while it doesn't have maybe kind of bullet point instructions for this is what makes a good data analysis, hopefully it provides a sample good data analysis to the learners and the educators using the book, where they don't have to kind of think in confines of what the title of that chapter is, but can put things together. And as you can imagine, these applications, case studies, are cumulative in the sense that the further you go down in the book, the more of the methods from earlier are highlighted. Rachel mentioned about color choice and accessibility for students with dyslexia. That's great. Yeah.
Are there any more questions or any questions that were asked earlier that may have been overlooked? Well, if you're typing or while you're waiting, let's, by way of the chat, let's thank Joe and Mina for a great session today. Thank you both for your knowledge and willingness to share. We'll wait a few more minutes to see if there are any other questions coming in. There was a couple comments throughout the presentation will be mailed out along with the recording of the webinar. So that should come here a little bit later today. I'm seeing a lot of thanks, but not a lot of questions. So I guess you all covered everything. So Joe and Mina, thanks again. Thank you all for attending. I believe this is the last scheduled webinar for 2021. So all of you, especially the regulars that I see on most of these webinars, have a wonderful holiday season, a Merry Christmas, Happy Hanukkah, Happy New Year, any other holidays that are celebrated during this time, and hope to see you back with Mary running the webinars in 2022. Thank you all.
Thank you very much.
Bye.
Thanks for being here, everyone.
Bye.